and I've already uploaded the new version. So nanti check out in your e-learning the latest slide for today. All right. So let's start. Today we will continue with chapter 6. Okay, we have finished chapter 5 with MOSFET. Okay, so we will continue chapter 6 with operational amplifier. Okay, or the short name for operational amplifier known as OP-amp. Okay, OP-amp. All right. Okay, so for in OP-amp, what we're gonna learn? We're gonna learn the basic operational amplifier. Okay, how the symbols, and then what's the types of amplifier. OP-amp. Okay, and how the characteristics and all those things. Okay, and then we're gonna look just a little bit about OP-amp modes and several parameters regarding OP-amp. And then for OP-amp, we're gonna go for two. It can be divided into two, which is linear or non-linear. Okay, it can be divided into two, linear and non-linear. So we're gonna look both applications. Okay, so for today, I hope we can finish the linear amplifier, or or kalau tak possible, we will continue tomorrow. Okay, so inside linear amplifier, there are inverting and non-inverting. Okay, inverting, non-inverting, and they have summing. Okay, summing application, which is also can be divided into two, inverting and non-inverting, and also voltage follower. Okay, voltage follower. So this is for linear applications. For non-linear applications, it can divide it into, we're going to learn about comparator and Schmitt trigger. Okay, only these two. So for linear amplifier, for linear applications, we will discuss more about based on mathematical analysis. Yeah, mathematical analysis. And for non-linear, we're going to discuss more about how to draw the waveform. Okay, waveform. All right, so let's proceed. Kenapa dia tak gerak? All right. So this is the introduction. So operational amplifier, also known as OP-amp. Okay, the short name is OP-amp, right? And amplifier is a device that accepts a varying input signal and produce a similar output signal with a larger amplitude. Okay, it will increase, as the name is amplifier, so it will amplify the amplitude. But sometimes they also will reduce the amplitude as well. Okay, so it will change the amplitude of the output, right? And most OP-amp behave like voltage amplifier. And they are the basic components used to build analog circuits. Okay, so if you want to build an analog circuit, OP-amp is the basic components that you have to use, right? And the name operational amplifier, why the name is operational amplifier? Because it comes from the fact that they were originally used to perform mathematical operations. So in ancient times, yeah, they are using the OP-amp as an mathematical operations to solve mathematical problems such as integration, differentiation, addition, and subtraction. Okay, so these are how ancient people, or during those days, yeah, they use the OP-amps. Okay, nowadays we're going to use this OP-amp inside our electrical circuits. Okay. Alright, so integrated circuit fabrication techniques have made the OP-amp device high performance operational amplifiers, which make the fabrication becomes cheaper, in compared to previous device, discrete device. In discrete device, they are used as inside a vacuums, so it makes the fabrication process of OP-amp becomes very, very expensive. But today, thanks to the technology for the integrated circuit fabrication, it makes the fabrication of the OP-amp become very cheaper. So op-amp has two inputs terminal. Okay, it has two input terminals. The inverting input, which is the negative input, okay, and also the non-inverting, which is the positive input, okay, the positive terminal. So inside op-amp, it's very rare to call the terminal positive terminal or negative terminal. Instead of calling positive terminal or negative terminal, we call the terminal as inverting terminal or non-inverting terminal. Okay, so it have two inputs terminal and only one output terminal. All right. And most op-amps operate with two DC supply voltage, one positive and the other one negative. Yeah, two opposite polarity of voltage. Right. So op-amps is a very high gain differential amplifier with a high input impedance, typically a few mega ohms, and low output impedance, less than 100 ohms. Okay, so we will look how the symbols look like. Okay, so this is the symbol of op-amp. Okay, input 1 and input 2. So input 1, if it is positive here, okay, so it is non-inverting. Negative is inverting. Okay, sometimes they're also negative here, positive here. So this positive negative sign is not fixed. Yeah, it can be right, either the positive down here or negative up here. So it depends. Yeah. So when you have this kind of symbol, please look where the positive and negative, where is the inverting and non-inverting terminals. Okay. Because sometimes it can be the other way around, right? So these are the inverting. If the minus terminal, if the negative terminal is here, so it means that the inverting input is here and the positive terminal is here, so it means that the non-inverting input is down here. Okay, and this is always becomes the output terminal. Okay, so since that I've mentioned, most op-amps operates under 2 DC supply voltage. So some of them, it can also represent like this. Okay, positive, negative voltages for these terminals, right? So usually this two is used, yeah, inside the electrical circuits. So okay, so these are the types of op-amps that you can find in the market, yeah. So yeah, okay, so it looks like this it looks like this kan kalau if you buy it in the market. So how to read? It has a lots of legs here. Kalau tengok dia ada banyak kaki dekat sini. So how to read? Tengok at the above here there is like semicircle here, semicircles here. Yeah. So semicircles from the left part. Okay, the left part of the semicircle, it is number 1, 2, 3, 4, and then 5, 6, 7, 8. Like this, right? So yang tu kalau it is in rectangular shapes, okay? But it also have another shapes which is circle shapes like this, very small circle shapes, yeah. So a small circle shape, you need to read anti-clockwise. Yeah? 1, 2, 3, 4, 5, 6, 7, and 8 here. Okay, so these are the two most common op-amps that can be found inside analog circuit. Different 4-1 types, either 8-pin or 14-pin. Okay, so it depends on the what types of circuits that you want to use, lah. Right? So what are the advantages of using op-amps? Okay. So op-amps, there's no external element is needed for stability. It is stabilized by itself. Yeah. So the gain value varies with feedback to one of the inputs. Okay. So the gain values you can always change the gain values. So it depends how you connected the feedback. Okay. And then the AC signal can be amplified without biasing. So there is no biasing for op-amp. So that's why if you look inside the earlier, yeah, biasing mentioned, because AC signal can be amplified straight away without any biasing by using the op-amp. Yeah. and the output nearly zero when the input is zero. Okay, so and also output can be in phase or 180 degrees out of phase with input. It means that you can change the output, either same phase or different phase. Okay. Okay, so let's look at the symbol of the op amp. Right, so these are the symbols of the op amp. So this, since that the negative terminal is here, so it means that this is the inverting part, and the positive terminal here, so it means that this is the non-inverting part. So this negative and positive, there is a current flow here. Okay, there is a current flow here. At the inverting, it will be I minus, and at the non-inverting, it will be I positive here. All right. So this is the DC supply to DC supply, which is positive VCC and minus VEE. Okay, why it is minus here? Because this is positive, so it should be connected with different polarity, right? So positive and negative, negative and positive, right? So these are the input impedance. Yeah, these are the input impedance inside the op amp, right? So this A refers to gain. I need to accept. Okay, A is the gain, all right. Ri is the input impedance. Ro is the output impedance. Okay, output, and so this is the output value, all right. ADM, so it means that gain with input, yeah. So will be the value of output voltage. Okay, so I positive, okay, I positive and I minus, which is referring to this part here. I positive and I minus is the currents into the amplifier on the inverting and non-inverting lines respectively. Yeah. So VID is the input voltage from inverting to non-inverting. Okay, input voltage from inverting to non-inverting. All right. And positive VCC, so it means that the currents, okay, the currents, the input voltage is, so it means that VID, so it means that the voltage here is from the inverting here to the non-inverting. Okay, so these are the currents, right? But the voltage will flow from here, positive to minus here, yeah. So positive VCC and minus VEE is a DC source voltage, usually around positive 15 and minus 15. Yeah. R1 is the input impedance. Okay, ideally infinity. Okay, the value is too large, which is infinity. And A is the gain of the amplifier, ideally infinity as well. This is also infinity, and makes the RO here, impedance also becomes infinity. Okay, what other infinity here means? Okay, sorry, output impedance is usually zero because this is impedance, this is infinity, so the output impedance is zero because there's no currents or voltage flow here. So what other infinity means? It means that the currents, yeah, the currents will not go inside here. Okay, currents will not go inside here. So same here too. The currents will not go inside here. Okay, so the currents will not go inside the op amp. All right. So it means that almost, yeah, the since that the input impedance becomes infinity because the value is too large and currents will not flow, so it will make that the output impedance becomes zero. Okay, becomes zero, right? And makes the output voltage here become very, very small. Okay, so the output voltage VO is ADM. A is the gain, yeah, gain. VID is the input voltage here, where ADM is the differential mode voltage gain. Okay, A is the voltage gain here. Okay, this is inside the op amp. Okay, we will look in details more during the applications later on. Yeah. So the ideal and practical op amp. Okay, so this is the ideal op amp. Okay, as mentioned before, usually ideal op amp, yeah, the value of input impedance and the gain amplifier is infinity. It means that too large. So Why need the output to be 0? Why need the output to be 0? Okay, later on nanti kita tengok dekat voltage follower. Okay, there is a applications kenapa kita sometimes we need the output to be 0, but usually the output is not 0 if there is a feedback, because in this case there is no feedback. In this case there is no feedback. There is no feedback. Usually nanti during the application there is a feedback here. So it means that instead of the currents flow inside the op-amp, the currents will flow here. Okay, so nanti kita akan tengok during the application the positive feedback and negative feedback later on. Yeah. Okay, so this is the ideal op-amp. Yeah, ideal op-amp usually the impedance is too big and also the gain is too big. So it means that for the ideal op-amps, the value of the voltage gain is infinite, the bandwidth also infinity, the input impedance also infinity. And because of this is all infinity, it makes that no currents can flow, can enter this and here. Okay, no current can enter terminal V positive, which is at here, and V minus due to the infinite input impedance. All right. So because of that, it makes the zero output impedance. The output impedance also becomes 0. And because of that, okay, it makes that the V output becomes very small. Okay, because of the zero impedance. Yeah, a zero input, so becomes the output also becomes 0. So an op-amps need two voltages to power it, usually VCC and VEE, that call it as rails. Okay, so these two DC, usually we call it as rails. Okay, kita panggil ni sebagai rails. Okay, rails, yeah. So in a circuit, V positive, which is at this part, yeah, at the non-inverting part, is forced equal to V minus at the V inverting part. Because of why? Sebab tak ada masuk kat dalam ni kan, the currents will not flow inside the op-amp, and because of the impedance is too large, so we assume that the V positive here is same with V minus here, and this is what we call as virtual ground property. Okay, this is very important, yeah. We call this as virtual ground property, right? And for the test, okay, for all questions, we will assume that op-amp is operating in ideal op-amp. But usually, of course, it's very hard to get the ideal op-amp. There is always akan ada a noise or akan ada effect during practical. So practical op-amp usually even though the input impedance ni is not infinity, but we can say that the input impedance value is very high. Okay, but it will not reach infinity, but the value is very high. Okay, the voltage gain also will be very high. Okay, and it will make the output impedance here not 0 exactly, but it will have a very, very low value. Okay, this is during practical op-amp, yeah. And it always generating noise. Okay, within the op-amp, inside here, there is always noise. Okay, so what is noise? Noise inside electrical device, we said that noise is the undesired signals, yeah, that will affect the quality of signal. Okay, that affects the quality of transmitted signal. So any distortion of output signal compared to the transmitted signal, we call that it has been affected by noise. All right, so these are what actually the practical op-amp is. But usually in calculations, okay, in equations, we will consider the op-amp as the ideal op-amp. Okay, that the input impedance is, the value is very high, which is infinity. Okay, but in practical tak lah infinity tu. Okay, but the value is very high, right? So since that the value of input impedance and the gain is very high, which is infinity, reach to infinity, so the value of V positive here at the non-inverting terminal and the value of voltage at the inverting terminal is same. Okay, force equal, force to be same. Yeah, and we call this as virtual ground. Okay, so please remember these terms, yeah, because this might come out during your final test part 1, especially, yeah, the section A part. Okay, so might be asked, so please know this, yeah, and what is virtual ground is, yeah. So the op amp transfer curves is look like this. So usually, yeah, sorry, this is VEE. This is not VCC. Okay, VCC and VEE. This is minus negative saturation and positive saturation. And this is the linear region where V output equals to the gain, okay, which is the voltage at the positive terminal, which is the non-inverting terminal, minus with the voltage at the inverting terminal. Okay, V positive minus V negative. All right. So this is just for you to know, yeah, the op amp transfer curves. Okay. So this will not related to your to the any analysis for the linear or non-linear, but this is just for your extra knowledge only. All right. So let's go into op amp analysis. Okay. So to analyze op amp, yeah, to analyze op amp for linear. For linear analysis, okay. First of all, okay, you have to know the key of op amp. Okay, so the key of the op amp is no current can enter op amp input terminals. Okay, as I mentioned just now, no current can enter this terminal because the impedance is too high. The impedance is reached to infinity. So it means that no currents can enter this op amp, right? Because of the infinite input impedance, yeah. And then the positive and the negative, which is the at the non-inverting and inverting inputs, are forced to be at the same potential. So it means that the V positive is minus, is always equals to V negative. Okay, so let's say if this is the inverting and this is non-inverting, let's say that the non-inverting is ground. Okay, so it means that V positive is 0. Okay, so it means that automatically V minus also will be 0. Okay, so V positive and V minus, non-inverting and inverting inputs always, yeah, is forced to be at the same potential, always same. Okay, and this property is called as virtual ground. Okay, this property is called as virtual ground, and use the ideal op amp property in all your analysis. Okay, we're gonna assume that the op amp is in the ideal op amp operation. Okay, even though we know in practically sebenarnya the value is not infinity here, but we assume that, yeah, in our analysis all the op amps work as ideal op amp. Alright, so let's look. Okay, dia kata dekat sini, right? Why the V positive and V minus here, V at the non-inverting and inverting is infinity, is because of the open loop gain. So what is open loop and closed loop? So let's look. What is the open loop and closed loop? All right. So op amp, yeah, can be connected by open loop or closed loop. Okay, either one, right? So open loop refers to a configuration where there is no feedback. Okay, it means that there is no feedback from the output back to the input. So it means that there's no connection here. From the output is not connected to the input. It is separate way. Okay, it is separating. So it means that the connection of this op amp is in an open loop configurations. So in open loop configuration, the gain can be exceed 10,000 and more. Okay, it makes the gain here becomes very large. Okay, because of the open loop configurations. So open loop configuration usually is applied to inverting amplifier, non-inverting amplifier, and also double-ended different amplifier, which is two opposite polarity. Okay, these are the applications for open loop configurations, and we will into detail about these two. Okay, inverting and non-inverting amplifier. And for closed loop, okay, for closed loop, usually it refers to a configuration where gain is reduced. Okay, gain inside here is reduced. In order to control the gain of an OP amp, it must have a feedback. So it means that inside this OP amp, there is a feedback. Okay, kalau dia connected to the negative part, so it will be negative feedback. If it is connected to the positive terminal, it will be positive feedback. Okay, so this feedback is a negative feedback if it is connected to the negative terminal. Yeah, a negative feedback reduces the gain, okay, and improves many characteristics. So the usage of feedbacks is to improve the characteristic of the circuit of the OP amp. Okay. So this feedback, yeah, is we're gonna look into detail when applications in inverting amplifier, okay, voltage shunt amplifier, and non-inverting amplifier, which is voltage series amplifier. Okay, so this is what the meaning of open loop and closed loop. So OP amp linear applications. Okay, OP amp for linear applications, it can be used as inverting, non-inverting, voltage follower, difference amplifier, summing amplifier, integrator, and also differentiator. But integrator and differentiator we will not discuss in this course, okay? Because you need to use differential and then integrate and all those things. It becomes very complicated for these two. So in this chapter for linear application, we will discuss more about inverting amplifier, non-inverting amplifier, voltage follower or unity follower, and then difference amplifier or subtractor, and also summing amplifier. Okay, so summing also can be divided into two actually, which is inverting and non-inverting. Okay, so it depends on how the connections, how the configurations of the OP amp. All right, so now, so that is the introduction part of OP amp. So let's look the OP amp linear applications for inverting amplifier. Okay, so these are the configurations of the OP amp, all right, for inverting amplifier. So if you look here, this negative here, the negative terminal is up here. So it means that this is the this is the inverting, okay, this is the inverting terminal, and this is the non-inverting terminal. And you can see the non-inverting terminal positive here is grounded, okay, grounded. So the V plus here and V minus is here, okay, V minus is here. So it means that V plus is equals to 0 since that it is connected to ground, okay. So the signal input is applied to the inverting input, okay, the minus terminal, okay. So that's why it is called as inverting amplifier, because the signal which is the voltage, V1, the signals, the voltage is given at the inverting input, which is the negative part of the OP amp. So that's why it is called as inverting amplifier. And the non-inverting, which is the positive terminal input, is grounded. So the resistor RF, ada baru masuk. So the resistor RF here represent as a feedback resistor. Okay, feedback resistor. So that's why it is RF here, yeah. So it is connected from the output to the inverting, which is the negative terminals of this OP amp, and that is why it is called as negative feedback. Okay, so for this inverting amplifier, yeah, inverting amplifier, it is always, yeah, the source of the voltage is only applied to inverting input of the OP amp, right? Okay, so that's why it is called as inverting amplifier. If the source of the voltage is applied to the positive terminal or non-inverting terminal of the OP amp, it is known as non-inverting amplifier. Okay, so if you want to know the name or the types of the OP amp configuration, please look where the signal input is. Okay, all right. So let's look how to analyze these applications. Yeah. So since that this is a linear applications, so usually linear applications kita akan solve. We will solve using mathematical calculations. Yeah, mathematical calculations. So kita tengok here. Yeah. So since that the positive terminal, the non-inverting terminal is connected to the ground here. So it means that V plus is 0. So as kita tengok tadi, if we have gone through at the key to solve the OP amp analysis, V minus is always forced to be equal to V positive. So since that the V positive here is equals to 0, so the V minus here. So where is V minus? V minus is here. Okay, V minus is at this part. So this is the V minus, yeah. So V minus is also equals to 0, all right. So as no current can enter V minus, why it is equals to 0? Because the impedance here is too large. So it means that the currents cannot enter here. So it means that the currents automatically will enter this terminal. Okay. So from the Kirchhoff's currents law, since that the currents cannot enter here, the currents that flow inside here, yeah, currents from this source of voltage, yeah, this source of voltage, the currents yang flow inside here will automatically flow here because of this large impedance for inside this OP amp. So it means that the currents will not enter here. So instead of enter here, all the currents will flow here. Okay. Sepatutnya if we think if the currents flow here, it will be parallel circuit kan. But since that there is no currents will enter here, so it means that the currents that flow at this part, okay, same with the currents that flow from this part. So I1 is equals to I2. Okay, so I1, how to solve I1? I1 is the potential difference, okay, from the Ohm's law, yeah, V equals to IR. So if you want to know I1, so V over R. So V is the potential difference between these two, which is V in minus V minus over R1. Okay, R1. Then since that V minus equals to 0, so it will be V in directly over R1 because of this value is 0. So that's why I1 equals to V in over R1. Okay, so this is the value of I1. Okay, for I2, same, we need to use the Ohm's law again. So I2, okay, usually it will be V minus the potential difference, right? V minus minus V out, okay, over R2. Okay, so since that V minus here is 0, so it will become minus V out over R2. So that's why there is a minus here. Okay, that's why there is a minus here because this is 0 and the potential difference here is usually smaller compared to here, right? So that's why it is minus V out over R2, okay, is equals to I2. And since that, okay, from 3 and 5, we know that I1 is equals to I2. So you can rewrite again this equation. So V out will become minus V in over R2 R1. Okay, so you will get this equation as final equation for inverting amplifier. So for inverting amplifier, it's always, yeah, V out equals to minus R2 R1, okay, times with value of this input voltage. All right. So kalau is given to you the question like this inside your exam, so if the configuration is exactly like this, so you can straight away use this formula. Okay, minus R2 over R1 times with the value of V input. Okay. Alright, so this is for the inverting amplifier. I hope until here is okay. Okay ke? Any questions for inverting amplifier?
Sensei, saya nak
Ya.
tanya.
Mhm.
Untuk yang open loop dengan closed loop tu maksudnya di-install untuk kawal dia punya voltage
Aha. Kalau macam ni sebenarnya kan, kalau macam ni if you look at like this kan, sebenarnya it will be this any feedback kan. This is the feedback. So usually kalau tak ada feedback ni, it will make this output voltage becomes zero kan. Sebabnya this input, macam mana nak kata, it is not connected to here. So the currents cannot flow inside here. So kalau lah letak berapa banyak, without, can you imagine here ya, without this R2, okay, this input, this part is not functioning, it will not function at all. Okay, without this one. Okay, the V output value will be zero sebab there's no feedback here. But because of the feedback here, it will make the V output becomes, there is a value for V output here. Okay ke? So this sebenarnya yang ni adalah closed loop lah. Yang ni adalah closed loop lah because it is connected to the feedback here. Right? Faham ke?
Faham.
Okay, alright.
Boleh saya.
Alright. So this is for inverting amplifier. So kalau dah faham inverting amplifier, I think we can go very fast for non-inverting amplifier. So for non-inverting amplifier, you can just the other way around, where the feedback is connected to the positive terminal or the non-inverting terminal. So that's why it is called as non-inverting amplifier. So for non-inverting amplifier, samalah ni all this, and this is the positive feedback. Okay, and how to calculate? Okay, the calculation now is quite different, right? The basic is same, but the calculation is a little bit different, where now the positive, the V positive here, ada signal. There is an input here, signal input here. So it is no longer zero, but the V minus here, the V inverting is zero, okay? It's grounded. And we know yang usually currents kita kena consider from positive to negative, right? So it will flow from positive here to negative here. So now it is no longer zero, yeah? V positive is equals to V in. Okay, since that V positive is equals to V in, automatically V minus is also equals to V in. Alright, so for this equation, V minus equals to V plus. Usually kita akan tengok the value for V plus. If the value of V plus is 0, then V minus straight away 0. If the value of V plus ada signal, so it means that V minus also akan jadi sama dengan signal for V plus ni. Contohnya, for example, if V plus is the input signal. Allah salah aja. Okay, for example, if V plus is input signal, so straight away V minus also will be the input signals too. Okay, right? So if V plus input signal plus with resistor value, so straight away V minus also will be input signal plus with the resistor at this part. Okay, alright. So be careful for here, yeah. So look first at the V positive here, V positive. Okay, so V minus always follow the value of V positive. Okay, so if V in this case, yeah, V positive, there is V input, So V minus here also will be V input. So no current, since that no current can enter this part, so it means that the I1 yang mengalir dekat through resistor I that flow through resistor R1 is always same with the value of I that flow inside the resistor R2. Okay, since that this part is actually It's actually open circuit lah, because yang ni it cannot go inside here, right? So I1 is equals to I2. And if you realize too that the flow of currents is from this part, from this way, right? Bukan this way, bukan, instead of this way, the flow of current is this way. Because of why? Because this is the negative terminal. Okay, the negative terminal. Kena be very, very careful. Currents is always flow from the positive terminals towards negative terminals. So, maksudnya dia akan mengalir daripada sini ke sini. Alright, it will flow from here to here. Alright. So I1 is this part, yeah. I1. So I1 is V input, since that this V plus, so this is V minus. So since that V minus is equals to V input, so it will be V input divide with R1. So that is the value for I1. Okay. For I2, okay, for I2, since that there is a potential difference between V output and V minus here. So V output, since that the current is flow from here to here, right? So V output minus V in. Okay, sebenarnya dia macam ni. Dia sebenarnya macam ni. V out minus V minus. So since that V minus is equals to V in, so that's why it is becomes V in like this. Okay, so that's why it is very important for you to know the flow of current, because if you don't know the flow of current, you will say that V minus minus V output. So this is wrong. Okay, V minus minus V output is wrong. Okay, it should be V output minus V minus, yeah. Okay, and divide with R2. So since that this so this is V in, yeah, this is V in. So you can rewrite the equation like this, right? You can rewrite the equation like this, and you will get the final equation. You will get like this. Okay, nanti you can try. After this, please try to redo again this equation. Why the final equation is like this. Okay, where you realize actually from I1 V input R1 ni, you can rewrite inside this equation. You can rewrite inside this equation where V input is equals to I1 R1. Okay, and then from here you can factorize, and it will become, from here you can factorize, it will become like this, and from here you can rewrite and it will look like this. And lastly, dia akan jadi 1 plus R2 over R1. Dia akan jadi macam ni, 1 plus R2 over R1 V in. Okay, for V out. Okay, for V out. So non-inverting, always these are the formula. Okay, so this formula it will not be given during your test. Okay, during your final test, during your exam, they will not given this formula. But this formula can be driven from this circuit. So once you understand the flow of this circuit, okay, you can always get this formula straight away. So that's why it is very important for you to know the very basic how to read this circuit. Okay, so non-inverting, nanti akan ada juga the linear applications for summing kan. Summing akan ada, for example, inverting and non-inverting. So this formula is very useful. This formula and this formula and this formula is very useful. So that's why it is very important for you to understand these two formula first. How they got or how they derive these two formula. Okay, sebab nanti these two formula we will use in summing application, which is also linear applications, but it will be more complicated a little bit. Alright, so okay tak for non-inverting? Any questions for non-inverting so far? Before we go to, I think we still have time for go to difference, yeah, after this. Voltage follower. Before we go to voltage follower. Okay, yeah. So let's go to, yes.
Kan current daripada negative terminal to positive terminal kan? So V out ni negatif ke?
Mana? Negative terminal from mana? Yang mana? Cuba mata ni. Yang mana? Current flow from
Current kan flow from negative terminal to positive terminal. Untuk yang I2 ni, so V
I2.
out ni negatif eh?
Yeah. Macam ni V out
okay.
negatif eh? Cuba mata. V out negatif. V out positif lah. Sebab dia positif and then dia flow to this negative. Macam ni, kalau from voltage, so current, dia ada the directions of currents, it depends on two tau. So kalau based on voltage, if you look at the kalau in case of battery, positive here, this is positive terminal, this is negative terminal ya. So the current will flow from positive to negative, betul tak? Betul tak?
Betul.
Okay. Tapi
Betul.
electron will flow from where? Negative to positive. So dia always opposite way. So dekat sini, so V out ni sebenarnya positive. So kalau in terms of voltage lah positive. So sini negative. Faham ke? Faham tak? Makin confused.
Faham.
Okay, faham Alright. So that's why the current flow from here bukan daripada sini.
Okay, thank you.
Alright. So, okay. So last kita pergi dekat voltage follower or voltage follower or unity follower. Yang ni very easy. Yang ni tak ada calculation or anything. Because yang ni tak ada feedback apa-apa pun. Okay. So dekat sini, okay, voltage follower and unity follower, V positive here. Okay, V positive here is equals to V input. Okay. So V positive is equals to V input. And as we know that as for virtual ground, V minus sama juga dengan V positive, right? V minus is equal to V positive. So therefore at this V output, so it means that this V positive, this V minus, so ni sama V input, so this is also input So this is always this is also input. So it means that V output is always equals to V input. Okay, V output is equals to V input. So in this case kan, kalau kita fikir, if you think, what is the purpose of this circuit? There is no purpose at all because the input is straight away goes to input. So there's no function of this output, right? There is no function of this OP amp. Tak letak pun tak apa. Better straight away je. Make the circuit, right? Not be complicated to using this OP amp. But actually there is a function of this OP amp. Okay, due to the infinite input impedance of the OP amp, no current at all can be drawn from the circuit before V in. So it is it will make that this part is actually isolated. Dia sebenarnya it will be like this. V in, isolate sekejap, and V output. Okay, this isolated part is actually is very essential. Okay, it's very important for microphone, for microelectrode, some device which is sensors lah usually, which is using a very high impedance sensors. It's very useful for this to use this kind of configuration because they need to isolate. Okay, they need to make two things separated but in one device. Okay, in one device like that. So kalau tengok kat sini, it's actually two separate because currents actually cannot flow inside this at all. So it will separate these two parts away, but the value is still same at the output. Okay, so that is the importance of this voltage follower or unity follower. Okay, so any changes of this voltage will also directly change at the output directly without any effect of this OP amp. So it is effectively isolate. Yeah. So it's very useful for interfacing to high impedance sensors such as microelectrode microphone method, right? So another 5 minutes. I think it's very difficult to go to amplifier subtractor because I think this needs some explanation. So far, any questions for that? From here, we're going to continue tomorrow. Any questions? And sebelum tu, maybe it will be interesting if you can prove this. Kalau boleh prove this before the class tomorrow also, I think it's very good. Okay, you need to prove this. Cubalah, try to prove this before our class tomorrow. Because this is very interesting part. Yeah. Okay, difference amplifier or subtractor. So kalau many of you can prove this, so we can go very fast tomorrow. Perhaps we can finish the chapter by tomorrow. I hope so, but I think not. Okay, so nanti try to prove this this equation. Kalau tak dapat, I think banyak je sekarang ni source dekat Google yang you can find how to prove this equation. Alright, so any questions? Again, for those yang masuk lambat just now, ada yang nak QR code attendance. For your test, test 2, the date haven't been confirmed yet. So far, the suggestion is on 10 June, which is, if I'm not mistaken, on Thursday. But that is just a suggestion. If you have anything on that date, if you have anything, please bagi tahu, please let me know, please inform me, so that I can suggest any other dates rather than that dates. Okay. So far the suggestion is 10 June, but it is not confirmed yet. Okay, some lecturers said not to do the test 2, but it's very difficult because test 2 can help you for your final exam. If not, your final exam will carry lots of marks. So so that's for just for information. So far on 10 June, the time might be during evening, 2:30 or 4:30. Macam tu lah. 2:30 or 4:30. Okay, so kalau ada apa-apa during that time, please let me know. So that I can suggest any other dates lah. Right? Okay. Any questions? No?
No, Sensei.
If no questions, so okay. So if no, we can end our class today and hope to see you tomorrow. Happy lockdown. Stay safe, yeah, everyone. Assalamualaikum.
Thank you, Sensei.
Thank you, Sensei.
Thank you.
Thank you.
Thank you.